Linear inequalities. Compound linear inequalities. When we talk about compound inequalities, we are referring to two inequalities that are joined by the word and or by the word or. It's like having two simple sentences to form a compound sentence. So we have two inequalities in one inequality. Those two inequalities form the compound inequalities. So the following are examples of compound inequalities. Minus 13 less than 3x minus 7 less than 17. We also have 3 less than or equal to minus 3x plus 1 less than 7, less than or equal to 7. 5 over 6 less than or equal to 1 over 3, brackets 1 over 2x plus 4, bracket close, less than 2. So all of these are examples of compound linear inequalities. We'll start by solving example A. So in solving this, notice that we have three sides of this inequality. We have this side, the first side, we have the second side, and we have the third side. This side on your left, the middle partition, and then the one on your right. So we're going to add, because this is minus 7, we're going to add 7 to both sides to eliminate this. So, sorry, not both sides, so all three sides. Add 7 to all three sides of the inequality. So minus 13 plus 7 less than 3x minus 7 plus 7 less than 17 plus 7. So minus 13 plus 7 will give us minus 6 less than minus 7 plus 7 will cancel out. This will leave us with 3x less than 17 plus 7 will give us 24. Now we need to divide the three sides by 3 so that our x is isolated. So our x is isolated. So minus 6 divided by 3 less than 3x divided by, let me write this down, divide through by 3. Divide through by 3. So less than 24 divided by 3. 3 will cancel minus 6. This is minus 2 less than x less than 3 into 24 is 8. So our final range of values is from minus 2 less than x to less than 8. So the range of values for x becomes minus 2 to 8. All the values within that range becomes the solution for this compound inequality. So how do we graph this on our number line? That's what we'll do next. So how do we graph this on our number line? That's what we'll do next. So if you watch, minus 2 less than x is the same thing as x is greater than minus 2. So x is greater than minus 2 will give us, let's call this 0, let's call this minus 1, let's call this minus 2. So I'll come here, make my circle, and draw my arrow in this direction. 1, 2. Then here we have x is less than 8. X is less than 8 is this. Let me call this 0. Let me call 2, 4, 6, 6, 8, minus 2, minus 4. X is less than 8 will be this, and then in this direction. So because this is a compound inequality, these two number line graphs are supposed to merge. So in representing this compound inequality on your number line, we would have this as our solution. 2, 4, 6, 8, minus 2, minus 4, minus 6. So this is minus 2. You come here, draw your circle. This is 8. You come here, you draw your circle, and then that becomes the solution for this linear inequality. Now for your interval notation, the interval of this compound inequality is simply minus 2, 8, minus 2, 8. So when you see this, you know that the range of this solution falls between these figures, minus 2 and 8. All three sides. So in that case, we have 3 minus 1 less than or equal to minus 2x plus 1 minus 1 less than or equal to 7 minus 1. So 3 minus 1 is 2 less than or equal to minus 2x plus 1 minus 1. This will cancel out as 1 minus 1 is 0. We are left with minus 2x less than or equal to 7 minus 1 is 6. So what do we do next? Here we are seeing that we have minus 2x here. So it will be proper for us to divide through by minus 2. 2 divided by minus 2 less than or equal to minus 2x divided by minus 2 less than or equal to 6 divided by minus 2. So this will cancel out. We have minus 1. Now remember, the rule says that whenever you're dividing both sides by a negative value or multiplying both sides with a negative value, the inequality sign will reverse. So this becomes greater than or equal to minus 2 will cancel out. This will be 1, that is x. Minus 2 will cancel 6. This will be greater than or equal to 3. So these inequality signs will change to this, and this less than or equal to change to greater than or equal to. Now I can rewrite 6 divided by minus 2 is minus 3. Minus 3. So I can rewrite this inequality by saying minus 3 is less than or equal to x less than or equal to minus 1. I've not changed anything. It's the same thing. Here we are saying 1 is greater than or equal to x. Here we are saying x is less than or equal to minus 1. Here we are saying x is greater than or equal to minus 3, and same thing as saying minus 3 is less than or equal to x. So nothing has changed. So these two are the same thing. So how do we plot? How do we represent it on our number graph? Our number line. How do we represent this on our number line? So if you take this first part by saying minus 3 is less than or equal to x, or by saying so if we take this first part, minus 3 is less than or equal to x means that x is greater than or equal to minus 3. So if you take this first part and you represent it on your number line, you're going to get this. Let's call this 0. Let's quickly call this minus 3. Let's call this 3. Let's call this 6. So you come here and then draw your line in this direction. Don't forget, you have to shade this because this is greater than or equal to. Then when you talk about x is less than or equal to minus 1, take your number line 0, 1, 2, minus 1, minus 2. You come here, minus 1, and your line goes in this direction because it is less than. Now shade this because it is less than or equal to. So these two graphs or these two number lines will have to coincide. So this brings us to our final solution. Now I'm breaking this down because if I just go ahead and draw the final answer, some persons may not understand. So this is 0. Let's call this 1, 2, 3, minus 1, minus 2, minus 3. So we have something here, and we have another one here. So this is shaded, and this is shaded. So that's the final answer for this question. So the interval for this will be minus 3, comma, minus 1. Minus 3, comma, minus 1. That will be the interval. So our next example is 5/6 less than or equal to 1/3 into 1/2x plus 4 bracket close less than 2. So in solving this, we would open up this bracket first, and that will give us 5/6 less than or equal to 3 times 2, 6, 1/6x plus 3 times 1 is 4/3 less than 2. Now we would find the LCM of this. So 5/6 less than or equal to LCM of 6 and 3 is 6. 6 into 6, 1 times x is x. 3 into 6 is 2. 2 times 4 is 8 less than 2. And and then we're going to multiply through by 6 so that these denominators will go away. So multiply through by 6. By doing that, we have 5 over 6 times 6 less than or equal to x plus 8 over 6 times 6 less than 2 times 6. So 6 will cancel 6, we have 5 less than or equal to 6 will cancel 6, we have x plus 8 less than 2 times 6, 12. Now what do? We subtract 8 from all of these sides because we need to isolate x. So subtract 8 from all 3 sides. So 5 minus 8 less than or equal to x plus 8 minus 8 less than 12 minus 8. 5 minus 8 is minus 3 less than or equal to 8 minus 8 is 0. So I have x left here less than 8 minus 12. 12 minus 8 is 4. So this becomes the solution. So how do we graph this on our number line? Quickly draw a straight line. Call this 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Now the lower limit is on minus 3, while the upper limit is on 4. Because we know that both lines would have to coincide. But remember to shade this one because it is less than or equal to. So what we have here simply is x is greater than or less than minus 3. X is greater than or less than minus 3 will be from here upwards. Then we have x is less than 4. X is less than 4 is from this 4 downwards. So when those two number line graphs coincide, this is what is produced. So this is our answer. So for the interval, we have minus 3, 4.